This is Eugene Stoner's 35 millimeter automatic cannon. It was designed for anti-aircraft use, and it was originally begun under a contract with the government of Iran while the Shah was still in power.
I'm not showing much of a level here, Phil.
All right.
Phil, what do you have?
Yeah, that's not too bad. But he said I can't trust that monitor. Okay, let's do the next one then.
Oh, what's the next? Okay, hold on.
Now let's do that one because they're related.
Volume recordings?
This is an Ares developed remote control turret which takes the 35 millimeter Talon cannon and is designed for light armored vehicles. Could be used either as anti-vehicular, in an anti-vehicular role, or it can be used in an anti-aircraft role. Note that there are no men or people in this turret, but where the people would normally be, the light blue structure is actually an ammunition container. The people controlling it would be inside the vehicle, but sort of out of harm's way. This type of turret is lower in silhouette than you would normally get if you had a person in the turret actually aiming the cannon. By putting the ammunition in the turret, you reduce the amount of distance you have to move the ammunition, which conserves space and also simplifies the shooting or transportation of the ammunition to the gun.
Volume recording.
The RCAAS stands for Remote Control Anti-Armor System. Eugene Stoner originally developed his 75 millimeter automatic cannon to be mounted on a light armored vehicle, either tracked or wheeled. In this model configuration, he has a proposed version which would be a towed howitzer, could be towed behind a truck, and which would be placed by itself in the field with a 6-round ammunition container, and then over an ordinary telephone line to a remote control station, it could be fired at enemy vehicles. The idea being that the people who operate the gun would not be where the gun was, and that would reduce the amount of exposure of the crew to enemy fire.
Okay.
This schematic of the RCAAS shows how a crew could watch a television monitor from a safe position and operate the gun. Depending upon the type of control panel you had, you might be able to operate multiple gun positions and thereby, from a specific vantage point, cover a wide area of terrain. The gun itself mounts a TV camera which tells you what is within the line of sight of the weapon. One of the objections to this concept by the military was that there was a possibility of the cable being cut, and the military preferred to have a radio link between the two systems. Stoner wasn't particularly enthusiastic about developing such a system because by introducing the radio link you would substantially increase what could otherwise have been an economical system.
Got it.
These are 3 of Stoner's automatic cannon for vehicles, basically the gun seen in the RCAAS system as developed for light armored vehicles. The gun on the left, the 75 millimeter AD, was the first gun. AD stands for Advanced Development. The 75 millimeter XM274 was developed under a joint Army Marine Corps project, and the 90 millimeter was an attempt to upgun or increase the caliber, but using the same basic technology. This gun was developed to fire telescoped ammunition, and it's intended to fire from that ammunition a fin-stabilized long rod penetrator type projectile as opposed to a high explosive. As a result, these guns are smooth bore. The long rod penetrator flechette, or sort of steel dart, is carried down that smooth bore by a 4-segment discarding sabot. The correct name for this ammunition is a armor-piercing, fin-stabilized discarding sabot projectile. And I think that's APDS, I don't know, FS, yes, that's right. And that is the sort of late 1970, early 1980 advanced technology ammunition, which is used in most anti-armor tank guns and anti-tank guns today. Okay.
You know, it occurs to me, if you want to look at some of this stuff before we leave, we can do that before the day is through, so we can look at the stuff we shot down there. Well, I mean, you spot check anyhow,
Yeah.
so, you know, but we have to institutionalize it.
Slow. Oops, wait a minute. Okay.
The cylindrical items in this picture are the telescope rounds that were developed by Ares for various weapons. The black cylinder, which is standing, and which is the other one which is lying on its side, are 90 millimeter projectiles. The two that have sort of the buff color, cream color center sections are the 75s. The 75 on the right is the early advanced development gun projectile. The one on the left is the current 75 millimeter projectile or cartridge. For scale, Stoner has placed in this picture an M50 series 20 millimeter round with the yellow projectile, the 35 millimeter that's used in the Oerlikon and Talon guns with the blue projectile, and on the right, the large projectile is a 105 tank gun projectile. What Stoner is trying to do is replace a shell the size of that 105 round with one the size of the 75 millimeter rounds. The other telescope round next to the 35 millimeter cartridge with the blue projectile is a 25 millimeter aircraft round, which has been developed for a high rate of fire Air Force gun, which is still a classified program.
Nobody crack any jokes about three escort gunners.
Well, I do actually forget that. Let me rewind. Well,
That's all right.
no, because you'll get the slate now.
There we go.
Sorry about that. Yeah. Get out of the way.
Polynesian room. Okay. Ladies and gentlemen, live from the Polynesian room, Tiny Bubbles.
Tiny bubbles
In stereo.
in the wine. Okay. Makes me happy. Wait, you gotta wait for the rest. Makes me fine. Oh, we doing echo.
We're doing echo, man. Only that's the only.
I guess
Fine. Oh, sorry, go
I mean, I
ahead.
like the background.
Makes
Yeah.
me feel real something.
Sound
Fine.
shop, but-
Fine.
Makes me feel.
Made possible with the funding from me.
And that was Mataluki Mui and Christiana Molioli singing Tiny Bubbles from the Polynesian room live at Aries Corporation. Thank you.
It's not healthy.
What do you do? Have a hard time getting them in and out of airplanes and all, or
No,
what?
it gets videographers killed.
Oh, well, it could.
Yes.
That's the reason you have telephoto lenses, isn't it? To stay far enough away from.
Not far enough.
You know, helicopters don't fly to beat the air into submission.
No, no. Am I out of your way there?
Yes, sir.
Is the data in this?
Yeah,
Oh,
that's
okay.
everything I need. This is so old.
Now, you want the disassembled then later to pull the bolt out? Or
Well, I think, yeah, if he wants, we'll do whatever he wants to do here. We'll,
Yeah, I don't think you need to take it all apart.
okay.
I don't believe.
the feeder off, but I can't get it off.
Yeah, takes a little doing. It might be all. Everything here is so sticky now you can hardly move the bolt. It's got goo in there, for probably preservative or something that's extremely hard to move it. This gun we tried to was tested, on the CVAS test, and worked spectacularly on the inaccuracy and performance and the whole thing on this turret here. And we tried to give the U.S. Army a free license on the thing, and they had no interest, says there's no requirement. That was 7 years ago, and now they're suddenly saying, well, hey, maybe there is a requirement, and we may be interested. But they decided after they ran CVAS that they wanted to start all over again on a 30-millimeter telescope round, which
That's
is what we
combat,
were
right?
combat. But now they're thinking that for a block mod in the Bradley, they could upgun it because the Russians now have a 30-millimeter high-velocity gun. And I went out to several years back. I'd talked to Jim Ambrose about this, and he was somewhat interested. So I went out and tried to about a year or so ago, no longer than that, 2 or 3 years ago, went out to FMC to try to get them to consider maybe working with us on it, and I thought I could manage maybe to get some type of a contract to get this in on some block mod, and they practically ran me out of the plant. They said, if you think we're going to do anything to make any waves to stop the production of the 25 millimeter, I said, you're crazy. We don't want anything to do with it. Now I saw some of these people the other day in Williamsburg, and they have changed their mind kind of drastically. But they felt that if Congress or anybody knew that there was a new gun available that worked real well on the vehicle, that somebody might suggest that they stop and start incorporating it. And they said that they weren't interested in anything that might interrupt the flow of production whatsoever. Then we might be a big pain in the neck, and stay away and be quiet.
Interesting. Where does the 35 millimeter Talon come from? How did it come into existence?
Well, it came into existence mainly because of a contract we had from the government of Iran. Wanted a 35 millimeter, specified the caliber because they were building the ammunition. They wanted their own design and something they could build in country 35 millimeter air defense system. So we took on the job and the contract to do the whole thing, including the fire control system, turret, the vehicle, the whole bit, which was what we call the Eagle system. So they funded the whole thing.
Was this one of Ares' first big contracts?
It was, yes, the first large contract we had, and I might add the best one we ever had. We had more freedom, latitude, less interference, and everything else of anything we've ever done.
Basically, it is they wanted you to do the job and
That's
get
right.
it done.
That's right. And it ended up with no report writing. We gave them reports in the form of video tapes or one of those little cassette movie things, and they said that was much more meaningful to them than all the reports that we could write, and therefore insisted on those about every quarter, which is quite interesting. But it worked out very well, very happy relationship, except that when the change of administrations, you know, over there really took care of that.
So if you're building or creating a design for a country which doesn't have a large industrial infrastructure, how does that affect the design of a weapon?
Well, in this case, what I tried to do on this was to make it simple enough that they could do it in their existing plants and know-how. I went over there and surveyed all their production facilities one time, and before this came about, and knew pretty much what their capabilities were. And they wanted to work with the same German companies that had set up a couple of production plants, and got us together with them. And we kind of worked hand in hand, and in the design, I knew how far I could go with what technology that could fit into that system. And so we had, during the development phase of this thing, we had this German company representatives over here, engineers, actually starting out on the tooling and tooling programs and everything concurrently with developing the system. And this company was Fritz Werner. And that worked out real well. Everybody got along well, and the thing was just going great guns, so to speak, until the Shaw had to leave, and that took care of the whole program. But it was done in a very short period of time, and I think very reasonable limits in the money.
What is the difference between designing a medium cal gun of this sort as opposed to designing small arms?
Well, mainly the fact that you're talking about much higher masses of parts, and you're talking about very expensive ammunition. So it pays then to go into considerably more analysis work than you would do in small arms, because the laws of physics prevail that you have to do a better job in analysis. And the other thing is, consider that the ammunition for this gun for test firing was, even production ammunition was running around $70 to $75 a shot. So you could run up a sizable amount of cost just in ammunition expenditures alone. And we actually built a 20 millimeter prototype in this design, and before we ever built the 35, in order to, you know, get some of the rough edges off and so forth.
Give you a round there. How much does, approximately how much does a round that size weigh?
Well, this ammunition standard 35 HE round is almost exactly 3.5 pounds.
And what's the weight of, say, a 5.56 round?
I couldn't tell you. It was quite a few per pound.
Okay, so one of your big problems is just moving something that
Well, that's
big
right.
through the feed system and into the gun.
That's right. Because of the high mass, you got to watch out on the amount of acceleration you can put on the system. all this ammunition, for instance, when you get into large caliber that's fused and large mass and with a primer system, you have to be very careful on the amount of impact or acceleration that you put on the thing during this handling it through the gun mechanism. If you exceed it, you can cause all kinds of problems. I know Oerlikon, in developing this ammunition and their weapon, went through a little siege one time where the during the ramming cycle, when the bolt was picking up the round, was actually firing the round of ammunition due to, and it was the inertia of the primer system was causing the round to go off. Slightly embarrassing. You ruin guns and everything else that way. So you had to actually stay within certain limits of on the velocities and the parts. And this weapon fires at nominally at 550 rounds a minute, and its bolt velocities that we're attaining in here are 2 and 3 times the velocity of a small arm bolt. Then you say, and then increase the mass by a factor of 10, and you're getting into some pretty high load systems that require very, very careful analysis and design to take care of those.
Earlier you said that you can get away doing a small arm as maybe a 1 or 2 man project, but when you get into something of this size, you really need a team of people.
That's true. You can, you know, for instance, I could do the initial schematics and layouts of this thing, and you might say that the idea how the system would work, and then having done that and established more or less the parameters of the design, the philosophy of the design, then you really, do the fact that the kinematics and everything are so important, you really have to do a very careful analysis job. It gets into a lot of mathematics, physics, and then to go along with that, metallurgy becomes super important to take care of the loadings, the extremely high loadings we're getting into. So stress analysis, kinematics and everything, like I say, become just as important as the basic design of the system.
And in this case, the gun is only one small element of a much larger system.
Right.
And so you are not only designing a gun, but you're designing a whole series of components and elements.
Well, we know a gun like this, for instance, has to be fed with some type of a feed system, and due to the fact that the ammunition weight is high, I had some experience working with Oerlikon on a 25 millimeter system, and I saw in their shop the difficulties that they're having with the Flakpanzer, which was a belt-fed 35, and almost 90% of their trouble was around the links and the belt feed, just trying to haul all that mass through the system. And I made up my mind right there that I wasn't going to get in that trap with a belt feed on this size weapon. So what I did is devised a linkless system for it. And then, of course, once I knew we were going to use that from scratch, and then designed a handoff or interface feeding system that was compatible with this linkless system. And that then controls some of the aspects of the gun design. So you really have to go back and start in kind of the beginning, like on the type of, you have to have an economical, compact feed storage system that's reliable, and then make sure the gun can feed off of that and be compatible with it, and so forth. And the other thing is, of course, we know a weapon like this has to be on some type of a mount, and we knew the requirements that were on it. We had to have twin gun mounts, so you have to mount these 2 guns to where they're accessible for servicing, where you can get the ammunition into the guns, and then very, very important, get the ejected rounds out of the system. And so you've got to keep all these things in mind, how it feeds, how it ejects and everything, how it's going to fit into the mount when you're designing the basic weapon. And this weapon, incidentally, ended up at about half the weight of the Oerlikon weapon, firing the same rate of fire. So, and it was done mainly by this tubular construction and, you know, just a general difference in philosophy and design. And that enabled us to put in a much lighter mount system and a pretty lightweight vehicle concept.
With guns of this sort, you get into significantly increased production costs. The Oerlikon guns are well known for their quality, but they're also well known for the fact that they're extremely expensive. Would this have been a less expensive gun to manufacture?
Oh yes, yes. It was considerably less. I think we were talking about something in the neighborhood of about half of what the Oerlikon gun would cost to build, due to its, basically the design concept on it. And it still has just, all the elements that are necessary. For instance, we have the integral recoil system built into the gun and not into the mount. And some of the larger ones, I believe, the Oerlikon systems, they put the recoil system into the mount. But even at that, we'll still be able to, cut the cost down. But I incorporated it in the mount or into the gun because, you're going to have it one way or the other, and there's a trade-off whether it's better to put it in the gun itself or into the mount. And I felt in this case it was easier to do. With this type of construction, we had a place for it, so we incorporated it right into the gun itself.
And you have what kind of buffing system did you incorporate into the?
Well, in the recoil system, we use a ring spring type buffer. It's called an Edgewater type spring in this country, and a ring fader in Germany. And it's a all metal type system with no hydraulics or pneumatics involved. And then in the buffer in the rear of the weapon that takes the bolt forces and returns the bolt into battery as fast as you can, we use a air type buffer. In other words, it's just a spring, an air cushion system. So it's very, very light and very, very efficient. Oerlikon uses a hydraulic buffer where they actually compress the hydraulic fluid using one of the silicone type fluids that is slightly compressible, and they use that. It's with the speeds that we're impacting this buffer, it's literally impossible to do it with a steel type buffer spring arrangement because the mass of the spring gets so high that it starts equaling the bolt weight and you end up nowhere.
So to coin an old phrase that you use every time you do something, you have to consider the consequences of that decision on other aspects of your design.
All right, everything's tied together. You make one little change one place, and something wrong or whatever will pop up somewhere else. So it's we had a saying around here for a long time: there usually are no small changes. They may appear to be, but the end results can be quite drastic.
Certainly no free changes.
Right, right.
And so on a gun of this sort, where the costs are higher and the consequences are probably more dire if you make a mistake, you really do have to do the analytical work up front.
That's right. After you get a design layout and philosophy, then you have something to work from. For instance, on getting the ultimate, high rate of fire out of this weapon, we had to use a considerably different type of bolt lock because this system has to unlock under extremely high residual pressures for two reasons. One, to get the rate of fire up, and the other reason is to handle the Oerlikon type ammunition. This is something a lot of people don't realize, but the Oerlikon type ammunition is a cold form case out of steel, no heat treating. We use heat treating systems in this country, but over there they don't. So when this thing finally goes out the line, finished, it's already work hardened to the point it has all the physical properties that it needs. But when it fires in a barrel, it immediately expands past its normal elastic limit and takes a set in the barrel and becomes very, very sticky. And if you would try to open this thing up under a considerable amount of delay, there's a real good chance you'd tear the rim off or ruin the extractor on the weapon. So the trick is to open it up when there's enough residual pressure to help blow the case out. And doing that, you need a lock system that can unlock under a high residual pressure that won't peel off the corners or anything. And a rotary lock doesn't lend itself too well to that.
And somebody winds up with some European 25.
Well, they don't intend to because the U.S. is going to make most of the ammunition anyway, and that was the excuse. I can tell you...
I tell you what, Murphy will bite him on that one.
Yeah.
He'll get them there. Okay.
But on this ammunition, to follow up on it, due to the fact that it does take a permanent set, when we fire this ammunition in a man barrel, where there's just a plain locked man barrel breech, the only way you can get it out is get a good size steel solid rod stuck down the barrel and a fairly good sized sledgehammer to beat on it to beat it out. And they also put fluted chambers in. Ehrlichman uses that to aid in it so that it doesn't tend to give the forward pressure component in the round, and therefore gets more going backwards and helps get the thing out. So it is a very difficult thing to extract. So with this system where you're using the high residual, you're going to always have a lot of force on this thing, and so as the bolt starts to go back, this type of lock, which works very, very rapidly, can skid off of its locking surfaces without galling up or anything. So that's the reason that we have to do that. And also, of course, we're going to unlock we're going to unlock under those high residuals anyway because we're trying to keep the rate of fire up as high as we can. So this weapon really doesn't need much help as far as the gas on the pistons are concerned. It's mostly, almost entirely a gas unlock, and the residual pressure is enough to drive the bolt back. But so our gas system doesn't have to be too big.
Did you do some special things with the extractor and ejector in this gun?
The extractor is pretty fairly standard. But one thing we did do is that the ejection loads could be very, very high and cause us some problems on ejection, tearing up the round and everything. So what we did is we've got these little wings that runs the ejector, and we can actually program the ejection through its stroke, and therefore, rather than just having it slam up against a fixed ejector or whatever, we can actually program that and give it an accelerated motion, tilting the thing around the extractor and kicking it out. And we found out that was really necessary in this size weapon, firing at these speeds.
Is ejection a problem when you get into large cases?
It is a problem, particularly associated with mounts again. In other words, whether you have to hit a certain window in the mount or direction to keep from hitting the vehicle or hitting part of the turret. And like almost any other weapon, you tend to have a ejection pattern moving around in relation to the speed of the weapon is firing. In other words, generally what happens in most of these systems, the faster the weapon fires, the more forward the ejection pattern tends to swing, and vice versa. So if you're shooting a gun that is under very cold conditions or poor lubrication or whatever, the ejection might be heading back towards the rear to the point that you could get a spin back round or hitting something you shouldn't hit. So it is a problem. It's definitely.
What I'm leading up to there is the way in which you solve that in the 75 when we get over to talk about the 75.
Right. Mm-hmm.
Okay. All righty. I think that'll do it.
Hey, one more time, Mr. Stone.
What does the 75 milliliter round weigh? What range?
I don't know. That's changed a bit over the years too, but it's not exactly light. Probably weighs 10 to 20 pounds or so.
That's what surprised me the first time I picked up one of the 105. Alrighty, now we've moved on to something even bigger and better in a sense. We're looking at the breech mechanism off of your 75 millimeter automatic cannon. Can you start off with a little bit of history of this project, when it got started, and what you were trying to do?
Well, originally, this goes back quite a few years, DARPA was trying to find an alternative anti-tank system that didn't depend on a heat round or shape charge technique. They were afraid that one of these days somebody might develop armor that could defeat that. And so they wanted a anti-tank kinetic energy round system. And with that, they also wanted, in particularly, a high rate of fire system. In effect, a machine gun that could defeat tanks, because in a mass armor attack, tanks could be coming in such great numbers that they could overrun conventional single-shot type systems pretty easily, and they'll have to have something with a very high rate of fire in order to hold its own. So we started out, we had this concept on this type of a system, and they also wanted to incorporate telescoped ammunition. So we came up with a couple of designs. This one was the final evolution of that design, using telescoped ammunition and literally making a machine gun of this size that would fire it. Originally, everybody thought that 60 millimeter would probably do the job, but then at the last moment before the contract was let, they requested that the size go up to 75 millimeter. And even the 75 millimeter, we've actually changed, I think, the ammunition configuration, I think, 3 different times in order to accommodate a more powerful round than original.
What does the projectile look like in this round?
Well, we fire basically 2 types of projectile. We fire an HE projectile, and we fire a armor-piercing, discarding sabot type projectile, fin stabilized. So in effect, we're firing a typical long, L over D type of a system, and we fire it through a smooth bore. This weapon doesn't have any rifling in it whatsoever. The whole idea of using the telescoped ammunition was the fact there again we could use a push-through type principle where the incoming round could literally push out the expended case. In this case here, you're seeing the breech in the loading position, and the rounds would normally be loaded from down below, and they'd actually push this expended round out the top of the weapon. And one of the reasons that I chose this type of a breech mechanism, which is literally a pivoting type of arrangement, as you see here, it goes down to and lines up with the barrel to fire and then comes back in the vertical position to load, is it greatly simplified the other part of the system, which was the ammunition feeding system and magazine system. In this case, where the rounds are, average out around 40 pounds apiece, this becomes quite an important factor. And what this did, by being able to tilt this breech, it literally took out, I would say, at least half or maybe 3/4 the amount of machinery it would take if it was a normal breech loading conventional system. So it greatly simplified the ammunition handling part of the system. It also, part of that is complicated by the fact that the gun has to elevate it originally at very high angles, and we had to have a system that was compatible with that. So this swinging or rotating breech actually contributed greatly to the ammunition feed system.
What kind of rate of fire can you obtain with this type of mechanism?
We've actually, in tests, we've fired them up to a rate of 2 rounds a second. And nominally, well, I think we're shooting about 1 round a second or maybe a little less now. And that limitation was put on greatly by the fact that the fire control system and stabilization system and everything had a difficulty in keeping up with any more than that. So it's turned out to be a fairly good rate.
What kind of rate of fire do they normally get out of a standard tank?
Well, in the standard 105s and all, I think that they're probably less than half that with an automatic loader. They probably take at least twice as long to do it.
Hand loading them?
Even with an automatic loader. Hand loading, I think you're up considerably longer than that.
Plus you have the human fatigue factor.
Well, that, and you also, in that case, you have an extra man in the tank, which contributes several tons to the weight of the tank, just putting that extra man in there and protecting him with armor. So this system lends itself to a complete remote system, which we have developed, where there are no men in the turret whatsoever.
Does that have the advantage of being able to move the ammunition storage closer to the gun, or at least some of the ammunition storage closer to the gun? So
Yes,
you don't
yes.
have to move it around as far in the vehicle?
That's right. It's a much more compact system. It also gives us, this system also has a capability of giving us a mixture of ammunition that the gun can discriminate which type it wants to shoot, and makes that readily available.
How does this overall system compare in weight with conventional single-shot systems?
Well, actually, this system as it is here is fair, consider the fact that this breech mechanism also includes the recoil mechanism, and actually we're talking about approximately the same weight as a single-shot system, all up single-shot system. There's a much.
When you get into conventional systems with auto loaders, you're really saving weight.
I think we are over the where we're handling conventional ammunition. We've had experience here building both types, and I don't think we don't have the 105 system here now that we've developed, but it's interesting to see the two side by side. You can draw your own conclusions. One of the things we can do on this is due to the fact that this tilts, this weapon doesn't have to go back to a zero position to be reloaded each time like most autoloaders do. In fact, what happens is that this tilting of the breech makes up for the difference of angle that the weapon might happen to be pointed, which is kind of unique in that position, so that it saves time and loading, and also greatly simplifies the loading system.
Could you lift that heavy 40-round empty shell there so we could sort of see what the shell looks like in relationship to the weapon?
This is what the shell looks like, and you can see it has hemispherical ends on it. That's the reason that if you project this around, would be a sphere. And this is just taking a section out of the sphere. That's to make everything fit when it rotates in position to fire. It takes up all the gaps and so forth. The shell or the penetrator is placed down inside of the round of ammunition, similar to the one that you saw in the cutaway of the 25 millimeter. So it's all buried inside, and you have to really look inside the round through this hole to know whether it's a loaded round or not. You can't tell by just looking at the outside. This happens to be an empty one now. It has metal end caps on it. This happens to be a plastic case, and the metal end caps do the job of sealing up under the high pressure gases.
Now, with that type of projectile, do you get much heat transfer into the breech block?
No, practically zero heat transfer during firing, because there isn't any hot gases washing on the breech block at all. So the barrel takes all the gas wash, and that's therefore the heat sink, and you get very little transfer back into the breech itself.
So you don't have to worry about things like cook-off, and,
No.
and you can keep up a fairly high rate of fire.
That's right.
So in a combat situation, you could actually use this at the rate you need to and not have to worry about shutting it down at some point.
Yeah, you don't have to worry about cook-offs, and that's not one of our safety considerations on this.
All righty, good. A moment ago, we were looking at the breech block. Are we okay?
We're going to need a new tape soon, though.
Yeah.
Well, this is going to be pretty short.
Okay.
All right.
A moment ago, we were looking at the breech block. Now, how does that breech block relate to the housing in front of you?
Well, this is what we call the receiver assembly, which is the part that actually takes all the parts of the gun, including the barrel and the receiver. And the breech block that we saw a moment ago actually slides right inside of this unit here. And this shell then has a back cover on it. And this actually protects the gun mechanisms from the elements. And in this case, it also has to be certain thickness to take fragmentations and everything from enemy action.
Before we were discussing new materials and new technologies. Is something like this receiver or the forward housing for the barrel, is any of that candidate for using composite or other new materials?
Yes, it is. In fact, we have made the barrel jacket, which is actually from this part forward that supports the barrel, out of composite, some of the later composite materials, and it's worked very well. In fact, there's probably no reason why we couldn't make this whole outer shell, and we looked into that, out of a composite material. We could save a considerable amount of weight. But part of that has to be also traded off on the customer's requirements on frag protection and so forth.
In having a couple of conversations with some of your engineering staff, the comment has been made that in all of your designs you are weight conscious, and that sort of reflects your origins as an aircraft industry person. Could you comment on that?
Well, yes. Actually, when you consider that any piece of military equipment now in the weapons field is eventually going to have to fly, and therefore weight is a big consideration. So I think that even in this case here, the vehicle this goes in has got to be air transportable. So it's extremely important to keep the weight out of the system. So it has a purpose watching that weight, and you really have to watch it.
That's one of the consequences of shifting from air transportation of hardware from where we used to use ships before.
That's right.
And also the demand for rapid deployment.
That's correct. That's particularly so, the larger the caliber gets. And then when you get into small arms, you've got the man to worry about and what he can carry. But that's all. I've always considered that rather a joke, because every time they take a pound off of the weapon, they give the man an extra 2 pounds of something else to carry. And his combat load hasn't changed one single bit in the last 50 years. It's still the same, even though he has a much lighter weapon system.
Behind you, there is a large yellow monster. It's a variation on the 155. That comes out of the work you're doing on that comes out of the same universal concern for air transportability. Is that correct?
That's correct. This is an attempt to come up with a new recoil mechanism that would allow a much lighter overall weight weapon. And that's exactly the reason for it, was to make it more air transportable, particularly with helicopters.
This particular version is a... Okay. And then we'll just get it. So the 155 behind you, that's what they call a test bed or a brass board. It's just to test out the recoil system. As it stands now, it's still made of primarily of steel components. Could that too go towards more lightweight composite materials in the future?
Well, the plan is to actually, where all these parts that you see in yellow, the majority of those will be made in a composite. That is the ultimate plan if everything works out. And of course, the composite against steel, you're talking about something that's less than 1/4 of the weight of steel for the same equal strengths.
But the laws of physics say that if you reduce the weight of all of that, then you really have to figure out a way to get the recoil under control.
That is correct, and that's this program we're on is only concentrating on the recoil mechanism, trying to get a more efficient system to allow us to go to a very lightweight overall weight gun. And that is actually the only part of it that we're working on really right at this point in time. They won't be able to go to the composite structure if they don't come up with a better, more efficient recoil system.
The problem of a recoil system, is that compounded by the fact that artillerymen like to shoot at different ranges and use different powder charges to do that?
Yes, I think we have, I think we're working through at least 7 zone charges, which means 7 individual powder combinations and projectile combinations. So it gets to be pretty complex on what they like to do. They like a lot of versatility.
So that creates problems for the engineer.
And the other thing that was a challenge on this is they want this recoil system to be completely independent of any man inputs. In other words, it had to sense, the system has to be able to sense immediately whether it's a high zone or a low zone charge, and then automatically and instantaneously make adjustments for that. They're trying to preclude Murphy's Law, where a man would have to turn a dial or something to match whatever zone charge be made. And I think that's a good, valid assumption, that if you put a dial or an adjustment on it, somebody will have it in the wrong position, so at the wrong time.
And you could pay the penalty of destroying a carriage or doing something more disastrous.
Of course, the unfortunate thing is you generally have to pay for that in complexity in order to make up for that input.
Smart systems generally are not simple systems.
That's right.
Okay. Yeah, maybe we could wrap up with a few words about the laws of physics. So you and I have been in a couple of circumstances together where we've been talking to people. It seems to me that oftentimes both users and technical people alike within the military R&D community want engineers in all kinds of circumstances to ignore those basic principles that Newton laid down a few hundred years ago. Could you give us a couple of minutes on that?
Well, I think that as we progress technically, get more sophisticated, people tend to flirt with the very, edge of limits to the laws of physics. They all try it. And in a lot of cases, when you're getting too close, sometimes you go over the line, and it always ends up that Newton was right. You're not going to make it. And be surprised how many people try in this business. In other words, and especially working with recoil problems and all like that, they can end up with something that may work but may be completely impractical from the standpoint that it could be darn right dangerous, or it can have unpleasant effects on the operator or whatever. So it's one of the things that has been popular in the last few years, especially when everything is going airborne and you're trying to get as light a weight system as possible. The old days, they didn't worry too much about it because it was going to go by ship or rail anyway, and the systems could be massive and heavy, and therefore you weren't flirting around the limits.
We've been with people on occasions also who want to do impossible things. They want to have a shoulder-fired launcher that'll kill a Soviet main battle tank. How do you react to that kind of, I mean, besides smiling and being amused, how do you address that kind of issue with people?
Well, most of these things, these types of things can be done, but the person that desires these things as a rule, you know, especially like in the user community, has no idea at what expense this might be. In other words, there's a lot of things that can be done, but if for instance, an anti-tank missile is going to cost, to do that job, cost 4 times as much as the tank costs, it really doesn't get you too far. And this is one of the things that that I fault the user on a lot of times, is the fact that they really have no guidance or don't do their homework on what the trade-offs are when they ask for these things, what the practicalities are in cost. Many things can be done if you just completely ignore the cost and say do it at any cost. We'll worry about that later. But we can't do that. We have to, for anything that's adopted by the military as a rule, has to be producible, and it has to be produced economically, or you don't get enough of them to do any good.
I think it's sort of the man on the moon syndrome. People often say, well, NASA could put men on the moon, why can't you kill a Soviet tank? Mm-hmm. And the point was that, to a large extent, NASA never had to account for the dollars. They were just able to, you know, say, look, we need to do this. Thanks for the blank check. We'll get back to you when we get to the moon. Mm-hmm. Well, in a real-world environment of a battlefield, you seldom have that luxury.
That is correct.
Okay. Good. Thank you. I think that